morning, students. This is Dr. GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today I will explain about outcome-based education. So what is the outcome-based education and what are the importance of outcome-based education and how to write COs and POs and PSOs and how to map from CO, PO and PSOs I will explain in this session. First, I will give a brief introduction about outcome-based education, and then we will write COs for this design of machine element subjects, and how many COs are there, and how to map the COs to PO and PSOs I will explain. So first of all, introduction to outcome-based education. So what is this outcome-based education? And then, so what are the important terminology related to this outcome-based education? So actually, this outcome-based education is a process of education. It's mainly focus on student quality of education, and it mainly focus on students what can they do and what they are expecting from the teachers. So all these things will cover in this outcome-based engineering education. So then only we will give quality education to the students. Students are able to learn new things, innovative projects, and after completion of our teaching, so student can able to write examination, able to do the different types of projects. Clear? So able to write the papers, research papers, journals. So all these things cover in this outcome-based engineering education. So that's why it is not what we teach. So in teachers, so what we are teaching in the classroom, that is not important. It's what you learn. So student, what they can learn from the teacher. So that is the important. So in this, the OBE is an educational process focus on what students can do or the qualities they should develop after they are taught. So what students develop the qualities after completion of teaching process. So it involves restructuring of curriculum, assessment, and reporting practices in education. It is reflect the achievement of high order learning. So then only it gives mastery in that in their field. So the students will get knowledge in that particular subject rather than how much they earn course credits. So both structures and curriculums are designed to achieve those capabilities or qualities. These two, the structures and this curriculum are designed to achieve their those capabilities or qualities. A model education where the students demonstrate what they know and are able to do whatever the required outcomes are. So whatever the required outcomes, but what they know and what they able to learn and able to speak out about a particular subject or topic. So an approach that focus on the students learning rather than teaching. So this is a important thing in OBE education, outcome-based education. So student learning is very, very important. So in this OBE, it addresses the following key questions. What are they? First one, what do we want the students to have or able to do? What, why, how? So these are the importance. So why do you want them to learn it? What is the importance of the learning? Why should they learn the COs? And why should they learn new topics? So how can we best help students achieve it? How they are achieving? So what way we are giving best things to the students to achieve the goals? So that is the important. So the how will we know whether the students have achieved it or not? So how can you assess the students after completion of your course? So how to test the students? What are the assessment methods are there? And then how do we close the loop for further improvement? So first thing is what we want the students to have or be able to do. So what they are expecting from us, and why do you want them to learn it? So why should they learn? So what is the importance? And then in what way we are giving things to the students? That is the best help to the students to achieve it. So how can you assess the students whether the students are achieved or not? And then finally close this loop. So that is continuous quality improvement, CQI. I will show you the diagram, the loop diagram. The principles of OB. The main principles of OB are four. One is clarity of focus. The OBE, one is clarity of focus, and the second one is design down, and third one is high expectations, and fourth one is expanded learning. These four are important principles of outcome based education. So what is this clarity of focus and design down and high expectations and expanded learning? One by one now I will explain. First, clarity of focus. So clarity of focus means teachers must be clearly focused on what they want students to know. First, clearly define the outcome. So what they want to know. So understand, be able to do. So in other words, teachers should focus on helping students to develop the knowledge, skills, and personalities. So that will enable them to achieve the intended outcomes that have been clearly defined. So first of all, clarity of focus is important. Teacher must be clearly define the outcomes and then understand and be able to do and focus on helping the students to achieve the set goals. The second one is design down. So design down means the curriculum design must start with a clear definition. So the curriculum before starting the academic year, you should give the well-defined curriculum to the students. So well designed. So that is clearly mentioned the outcomes that students are to achieve by the end of the program. So once this has been done, all instructional decision of teaching and learning are then made to ensure the achievement of the intended outcomes. So once this has been done, so definitely they will achieve the outcomes. So that the curriculum design is very important in OBE, outcome based education. Next with high expectations. So teachers uh, should establish high challenging standards of performance in order to encourage the students to engage deeply in different projects, and then what they are learning, and help the students to achieve high standards is linked very closely with the idea that is successful learning promotes more successful learning. So it means the high expectations always the teacher should give to give more expected values to the students, and teacher should give to encourage the students to engage the students in different types of quality projects, and give quality assignments. So these expectations to teacher should establish, and teacher also help the students to achieve whatever they given standards, to achieve their high standards. So then it will be helpful for successful learning. Next one is expanded learning. So expanded opportunities in teaching learning process. So a lot of opportunities are there to learn different things, innovative things. So teacher must try to provide expanded opportunities. So give different opportunities to the students. So behind the curriculum. So that, however, most students can achieve high standards, but if they are given appropriate opportunities. Students are able to achieve high standards if you are given more appropriate opportunities to the students, then only it will be possible. So that's why always the teacher must give or provide the various opportunities to the students. So expand, if the teacher can expand their learning methodology. So this principle is based on the idea that not all learners can learn the same thing in the same way and in the same time also. So give a topic or give a assignment to some students, but you can't expect same output from each batch. So give an idea to some batches. So different types of learners are there. So that all learners can learn the same thing at a time, and will not achieve at the same time and same quality. Clear? So some students are achieve their high standards. Suppose if you are provided opportunities. So characteristics of OBE curriculum. In OBE curriculum, what are the characteristics? In this, program objectives, and then program outcomes, and course outcomes. Program objectives, program outcomes, and then course outcomes are the major characteristics of OBE curriculum. While designing the curriculum, you should remember to address these program outcomes or course outcomes and program objectives. And then components of OBE. So what are the components? First component is curriculum, and then this one is curriculum, and then assessment task, and the smaller one is instruction methodology. So bigger one is curriculum, and then smaller circle is indicates assessment task, and the third one smaller one is instruction methodology. These are the components of OBE. Next, a model hierarchy of outcomes. Vision and mission of the institution or the faculty. So, and the next one is program educational objectives, PUOs. So, this vision and mission of the institution or faculty also can define their individual vision and mission and PUOs. These two are long-term outcomes. Next one is program outcomes, POs. And then learning outcomes of the subjects, the particular subject COs, course outcomes. These two are short-term outcomes, program outcomes, and then learning outcomes of the subject or COs of the subject. The long-term outcomes, these two are long-term outcomes. Why? Because vision and mission of the institution is very, very broadly how to expand. And program educational objectives also defined. And outcomes and COs are short, particularly for our program subjects only. So, the teacher assessment after completion of your teaching methodology. So, how can you assess the students? There are different methodologies are there. One is direct assessment and indirect assessment. So, direct assessment, we will conduct midterms and final examinations. And then indirect assessment, we will take feedback from the stakeholders. Assessment, direct, and indirect assessments. So direct will take CIE exams, SCE exams, and classroom assessments. Indirect feedback from stakeholders. Feedback. See, in this diagram, stakeholders' mission and vision. Take their mission and vision, stakeholders. So involved in this stakeholders, parents, employers, other institutions, professors, eminent professors, and parents. So take their feedback and take their opinion. So involve them into curriculum design. Take their opinion and design a curriculum. After that, program objectives. So define POs, program outcomes, and learning outcome of subjects. Now, after define of this the program outcomes, so here this is a continuous process. Program outcomes to program outcome, program objectives and program outcomes, and the learning outcomes of subjects. These COs, course outcomes, and then do the analysis. Do the analysis. Take the assessment. Supposed to take the program objectives and assessments and analysis, and then continuous quality improvement. To continuous quality improvement. Similarly, the second one, program outcomes, do the assessment and then analysis and continuous quality improvement. In course outcomes also, assessment and then analysis and quality, continuous quality improvement. So this figure shows the flow chart, the loop diagram of OB education assessment. So now, coming to our subject, the design of machine elements. The course title is Design of Machine Elements. Up to now, we have learned what is outcome based education and what is CO and what is PO and what is the assessment methodologies we have learned. Now, how to apply OB education to our subject, design of machine elements. So in this is a core subject. So number of lectures are 3, one tutorial and credits 4. So like this, we will define the subject, the course code. This is for a 4th semester. So now, what are the course prerequisites? So in earlier semester, what subjects you have learned before studying this subject? So in this semester, 4th semester, this design of machine elements you are going to be learned. So before learning, you should know some principles, some basics related to this design course you have studied in 3rd semester. So that is a prerequisite. So that is a course code is MEC05 and the prerequisite subject is solid mechanics. So the subject deals with the materials and then materials characteristics and types of materials and testing methodologies. So how to calculate the stresses, various stresses when the object is subjected to different loads. So how to draw the shear force diagram, bending moment diagram. All these things you studied in this solid mechanics. So those stresses, torsion formulas and bending formulas how to apply for this design of machine elements. So then only you can design a machine component. So what are the stresses units, what are the strain, different types of strains, all these things you should learn in this solid mechanics. So now coming to our design of machine elements course overview. So actually the machine design emphasize for influence the fail-safe design in the mechanical system using different theories of failure modes. So always you should design safe design of the mechanical components using different theories of failures are there to avoid failure. So always you should use good condition, good design, a safe design condition only. So different theories are there. Five theories are there. The design of the machinery members focuses mainly on the design of machine elements subject to various types of loads and components, including joints and rivets and welded and threaded joints. Permanent type joints are there and temporary type joints. Riveted joints and welded joints are comes under permanent type joints, and threaded joints example for temporary joints. So what are the forces acting when the machine elements are subjected to various loads? How to apply the different theories of failures, and finally how to design a machine component. So how to design a shaft and springs using design standards and BIS codes of steels. What are the design standards? What are the tolerances? What are the fits? How to apply these standards to the mechanical components while designing? So how to fix the shaft diameters? How to take standard parts? So all these things we will learn in this subject. The design philosophy is based on the strength, stiffness, and material selection for manufacture of machine elements. So material selection is very very important for designing. So that's why before designing, you should learn, you should know about that particular material. What are the properties of material? So then only you can apply, you can select the proper material to the your machine, your design going to be design product. So without knowing the material properties, suppose you are selected wrong material for a good design. So what will happen? So ultimately, the component will fail. So that you should know the properties of the material and select a material. Selection of material is very important thing in design. In design process, you should learn in this subject how to start the design. So what are the important considerations you should take? All these things you will see in this course. So the defined objectives are in this subject. The students will try to learn. First one, the machine element design process. Already I told you the design process achieves the desired constraints for strength, rigidity, and reliability. So always your design process that achieves the your desired constraints, your desired goals for strength and rigidity and reliability. The process flowchart you should know. So student try to learn this design, what is design process, and how to achieve the desired constraints. The second one is the nature of loading for the application of theories of failures. Different theories of failures are there, like maximum principal stress theory, maximum principal strain theory, and maximum principal shear stress theory, maximum strain energy theory, and maximum distortion energy theory, respectively. So like this, different theories are there. So what is the nature of loading and how to apply these theories for a particular mechanical machine elements under different loading conditions? The student will learn. So in this, the student will also learn the fatigue properties, different types of properties of the material, In the mechanical properties are very, very important, like strength, hardness, toughness, malleability, fatigue, creep, etc. So suppose your nature of loading, means fatigue loading. So how to apply the fatigue load stress concentration factors, how to avoid the failure. Whenever the component is subjected to cyclic loads, the component will fail due to the fatigue property. So how to avoid this failure? So which theory is useful? The student will learn, and also student will learn in this topic. Uh, Whenever the component is subjected to the combined stresses, like variable stresses. So how to calculate the variable stress? How to calculate the fatigue strength for a particular number of cycles by using SN curve, and then by using different theories are there, like the Soderberg theory line and Gerber parabola and Goodman line method. By using these methods, the student will try to calculate fatigue strength of a particular material. In third objective is students will try to learn various permanent and temporary type joints. In engineering applications, various joints are there. The joints are classified into permanent and temporary. So permanent type joints are welded joints and riveted joints. In this temporary joints are bolted joints, couplings. These are temporary joints subjected to various loading conditions. Fourth one. So the design procedure for various power transmission elements on the basis of strength and rigidity. So what is the design procedure? So for every design, every machine element has one design procedure. According to the design procedure only, how to design the component. These are the course objectives. Next, course outcomes. After successful completion of the course, the students should be able to learn. First CO1 is outline the knowledge of design process and the design standards, theories of failures, analysis the stresses and strains. Various types of stresses are there and strains, and for various machine elements. So outline the knowledge of design process. So the students should be able to tell after the completion of this course, after completion of all units, they can explain about design process and design standards. So this Bloom's taxonomy comes under understand. So understand the knowledge. And then CO2 is next develop. In first case, in first CO1, so knowledge gain and then apply whatever you gain knowledge for particular topic for design for various components, mission components. The second one is develop the design procedure of riveted joints and welded joints for various engineering applications like boilers, pressure vessels, and ships, trusses, etc. So rigid joints are used in this boilers making and pressure vessels. So apply. The level of Bloom's taxonomy is applied. And then third one, classify various types of keys and quarter joints. This one also comes under understand. So here, various types of keys and quarter joints. First classify how many types of keys are there and how many types of quarter joints are there, and the joints used to employ secure to gears. And CO4 is develop the design procedure. So understand first joints, the types of joints and keys, and then develop a procedure. So the procedures of knuckle joint for different loading conditions in profiler applications. So CO5, select appropriate design procedures on the basis of strength and torsional rigidity for shafts and couplings. In this, the students should able to learn, able to learn design procedures on the of the shaft. The shafts are designed on the basis of strength and torsional rigidity. For shafts and couplings, remember, so already you have learned procedures, and then recall those procedures, whatever you learned, and select the design procedure for our component. Final one, the CO1 is evaluate. So evaluate the natural frequency, energy storage, and stresses related to springs. Whenever the springs are subjected to various loads, static or fatigue loading, evaluate the forces and energy and stresses and natural frequency to avoid buckling and surge. First, evaluate. So this is the order of Bloom's taxonomy is understand, apply, and understand, apply. Here 2 apply are there, 1, 2, 3, 2 understands, and 1 remember and evaluate. So after successful completion of this course, the student be able to develop and classify and select and evaluate the various machine components for different applications. What are the program outcomes? So defined the program outcomes are 12 program outcomes. The PO1 and PO2 and PO3 are elaborated like this. Engineering knowledge, first one is. So whatever you learned in previous semesters in 10 plus 2 level and for your first year course. So apply the knowledge of mathematics, science, engineering fundamentals to get the good solution or optimal solution of complex engineering problems. And similarly, problem analysis, identify the problem and formulate and review the research literature and analyze. So here, problem analysis, after completion of problem analysis, design and development of solution. So design solutions for complex engineering problems and design system components to meet the specified needs with consideration for the public health and safety also important. The whatever you design, the product should give useful work, and at the same time it should give good health to the public, not onto the public and society and environmental considerations also you must consider while designing or development of various solutions. Next, PO4, conduct investigations of complex problems. After designing or development, investigations, do testing. So use research-based knowledge and research methods, including design of experiments. Different types of experiments are there. So conduct experiments to get the good results. And finally, provide and valid conclusions. Similarly, PO5, modern tool usage. Create, select, and apply appropriate techniques. If any new technique you are using for your course outcomes, so select this PO5. Only you are conducting investigations, PO4 useful. You are designing the PO3. So these POs are depends upon your course outcomes. So the engineer and society, PO6. So apply reasoning informed by the contextual knowledge to assess the societal problems, health issues, and safety conditions. So all these relevant to the professional engineering practice. And PO 7, 8, and 9. PO 7 is related to the environment and sustainability. To understand the impact of professional engineering solutions and demonstrate the knowledge of need for sustainable development. And you should follow the ethics, PO 8. So apply ethical principles and commit to professional ethics and responsibilities and norms of the engineering practice. For every engineering practice, you should follow ethics and apply ethical principles. So next, individual and teamwork also important, PO9. Function effectively as an individual, a member to lead or leader in diverse teams and then multidisciplinary settings. This PO is related to individual and teamwork. This is useful in doing project works. Next, PO10 is communication. Communicate effectively on the complex engineering activities with the engineering community. The engineering community share the knowledge very effectively. So that's a communication is important. So able to write and tell the effective reports and design documentations, make presentations. So next PO program outcome is project management and finance. Demonstrate the knowledge and understanding the engineering and management principles to apply these to one's own work. The project management, how to manage the project, how to get the optimal results, how to control the finance things in cost point of view, manage projects and multidisciplinary environments. This is related to PO11, project management and finance. The last PO is lifelong learning. So here lifelong learning recognize the need for the having the preparation and ability to engage in independent and lifelong learning in the broadest context of technological change. So every day, so the new things are day by day, technology is updating, new things are coming. So day by day by changing. So that so learning skills are important. Always learn new things and continuous for continuous improvement, continuous quality improvement. The lifelong learning is very useful. That is comes under PO 12. These are the POs defined. Now, so how many POs are related to our subject? Which POs are meeting the our COs according to our course overview? So you have to select first COs and then define the COs, course outcomes. Here, how program outcomes are assessed. So, your program outcomes are suppose you have taken in this related to this subject PO1, engineering knowledge, the strength given 3, very high 3. Why? Because the knowledge of mathematics science is very important for this design subject. So, how do you assess? By using CE and CAA and EAA exam. These are the assessment tools. So final examinations through and semester examinations and continuous improvement assessment and ATT, AAT tools, conducting quiz assessments, assignments. So here, second one is PO2, problem analysis. Here, identify the problem and formulate and conduct research review literature. So the strength is the weight is given 1. So this is a medium, very low. So in this subject there is no analysis. Research based analysis we are not doing in this subject. Some topics are there by using different theories. We will calculate the optimal solution. The assessment also same. AAT, so alternate assessment tools and CAA and SWE. And here, third PO, design and developmental solutions. Design solutions for complex engineering problems and design system components to that meet with the specified needs with appropriate consultations. Point of public health and then safety purpose. So the strength is here selected 1 given. So 1 source here low, 3 very high and 2 medium. So we will assess this PO by using these tools. Direct assessment tools. These are direct assessment tools. Next, POs. PSOs, how program specific outcomes are assessed. So here the specific outcomes are here mentioned PSO1 and PSO3. To formulate and evaluate engineering concepts, design, thermal and production to provide solution for technology aspects in digital manufacturing. This POs related to particular program. The strength given 3. And proficiency here we will assess by using research papers, industry exposure. So here industry exposure is important, and then make use of second PSO3 is computational and experimental tools for creating innovative career paths to be an entrepreneur and desire for higher studies. These PSO related to our program So and then the efficiency, the proficiency will assess by using research papers and industry exposure. And finally, we'll map the COs, CO1, CO2, and CO3, CO4, CO5, CO6 to PO1 and PO2, PO3, and the total 1 to 12 POs are there. But we are selected, the related POs are the subject point of view 1, 2, and 3. And PSOs are here, PSO, this PSO1 and PSO2 is, there is no PSO2 and PSO3 only. So mapped with the help of tick mark here shown, the CO1 mapped with mapped to PO1 and CO2 also mapped to PO2. Clear? And the CO6 mapped to PO3, and PS was also mapped. And then finally calculate attainment. After the completion of assessment, we'll calculate attainments. Then only we should know the student achieved or not. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.